On 23 March 2012, NASA Mission Control informed the crew of International Space Station in space on radio that many micrometeorites were going to hit the ISS after 6 minutes. This radio message caused panic in the entire ISS. The astronauts had so little time that they could not even change the direction of the space station during this time. But the question is that in the part of space where the ISS is present, there are countless micrometeorites. So how does the International Space Station, i.e. ISS, protect itself from these meteorites? How is this task accomplished without fuel and without the help of Earth to change the direction of the ISS, which weighs as much as 380 vehicles? How is the ISS as big as a football field taken from Earth to space? And how is it contacted when the ISS is on the other side of Earth? Built at a cost of $150 billion, or 12,375 billion rupees, the ISS is a home for humans in space whose example is unmatched in history. Hundreds of high-tech parts have been used to build it. It has 16 pressurized modules, which include separate modules for living and sleeping, an observation deck, and separate modules for 6 science labs, all of which are interconnected through airtight tunnels. Along with this, many spots in the ISS are still vacant, some for parking extra capsules, and some have ISS's lifeboards parked permanently so that in case of an emergency, if there is any issue, these lifeboards can safely take the astronauts to Earth. International Space Station is the biggest space station ever built. As big as a football field, the ISS is of course 400 kilometers away from the Earth, but still it can be seen from the Earth with the help of binoculars. Or if you want to estimate its size from a real-life object, then understand that the bottom or the base of Burj Khalifa is spread out to the extent that International Space Station is even bigger than that. The total weight of the ISS is 460,000 kilograms. This is the same weight as that of 380 cars or 25 passenger buses. But the question is, how did such a heavy and big ISS go into space? ISS started with just 2 modules and both were connected to each other in space. One module was made by America and the other by Russia. After the breakup of Soviet Union in 1992, America and Russia collaborated with each other and both the superpowers decided to build an international space station in space. First, Russia sent a module named Zarya into space, and then America sent its Unity behind it. Flying at a speed of 27,000 kilometers per hour, Unity followed Zarya. On 20 November 1998 at 6:40 a.m., these 2 modules connected to each other 400 kilometers above the ground, and thus the International Space Station was born. Since then, in the last 26 years, engineers from all over the world have together built their own modules and sent them into space through rockets and connected them to the ISS. Today, apart from US and Russia, European and Japanese modules are also connected to the International Space Station. From the year 2000 till today, European and Japanese modules are also connected to the ISS. For the last 24 years, not a single day has passed when it has been empty. All the time, astronauts from one country or the other are present in it. Inside the ISS, all the facilities that should be present in any superstructure are present to fulfill the needs of the astronauts. Oxygen is the most important among them. A human can survive without food for 3 weeks, without water for 3 days, and without oxygen for only 3 minutes. 400 kilometers above the ground, where there is neither atmosphere nor oxygen to breathe, the biggest challenge for the ISS is to provide fresh oxygen to the astronauts. An average person needs 15,000 liters or 22 kilograms of oxygen per day. For the 9 astronauts living in the ISS, providing about 200 kilograms of oxygen per day is really a big challenge. Here, the astronauts have several days of oxygen supply in tanks, so that if the system fails, the supply of oxygen is sufficient till the arrival of rockets from Earth so that the astronauts can survive. Today, technology has become so advanced that oxygen supply can be sent from Earth to ISS in just 6 hours, but only if the rocket launch is successful. This method is good but very costly because it costs $200 million for a cargo rocket to go from Earth to ISS. Food and other supplies, worth 1,650 crore rupees, are sent once in several months, but it is very difficult to use rockets again and again to meet the oxygen demand of 200 kilograms per day. That is why ISS produces its own oxygen without dependence on Earth. There is a small machine in it, which is nothing but makes oxygen by using water. When electricity is passed through water, it breaks into two parts, hydrogen and oxygen. Hydrogen gas bubbles get collected on the positive electrode, and oxygen gas bubbles get collected on the negative electrode. Now, if the same experiment is done on Earth, then these bubbles automatically get separated from water, because obviously, the weight of gas is less than water, but there is no gravity in space. The weight of gas is the same as that of water. That is, it is almost zero. So now to separate oxygen gas from water, this machine is rotated in a circular motion, which creates centrifugal force, which works as an artificial gravity. Due to rotating in a circular motion, water goes to the sides, and oxygen gas remains in the middle, which the machine itself collects and puts in the container. Now here you must be thinking that if oxygen is made from water in ISS, then from where does water come in space? Here also, brilliant engineering shows its magic. The hydrogen gas released in this process is collected from the air coming out of the astronaut's breath. Water is again formed by reacting it with the carbon dioxide gas, and finally, methane gas is left, which is wasted in space. Making oxygen for the International Space Station is a very big challenge in itself, but an even bigger challenge is to preserve this oxygen, because if even a small hole is made in the space station, then the result can be very terrible. In a second, the space station will explode and be torn to pieces. The example of the Titan submersible, which was destroyed recently, is in front of us. The pressure in the ocean is high, whereas Titan had controlled pressure. As soon as its hull leaked, the pressure of the ocean compressed it badly in less than a second, but in space it is exactly the opposite. Here, the pressure outside is zero, whereas the pressure inside the ISS is maintained. Just like Titan, if there is even a small crack in it, then it will decompress and explode. At the height at which the ISS orbits the Earth, there are a lot of space debris which are moving in space at a very high speed. These include parts of satellites and hundreds of other things. Small and big meteorites. Then the question arises that how does the ISS protect itself from these, right? The International Space Station is orbiting the Earth at a speed of 27,000 kilometers per hour. Its speed is so high that if it flies near the Earth at this speed, it can cross the Pacific Ocean in just 25 minutes, the same Pacific Ocean which commercial planes take 13 hours to cross. If it collides with a meteor as big as a grain of sand at this speed, then it will be like a car colliding with a tree at a speed of 80 kilometers per hour. On 23 March 2012, NASA Mission Control radioed the ISS crew that some space debris is heading straight towards the ISS. No one knew how big this debris is. They were informed about it just 6 minutes before. The entire crew immediately went into the lifeboats, but luckily the space debris passed very close to the ISS without touching it. But the ISS cannot be left to luck every time against a meteor. To protect itself from small particles, the hull of the ISS was made of bulletproof material. Just like a bulletproof vest has different layers, the hull of the ISS was also made of different layers. It was made by mixing different layers. The outermost layer is of aluminium. After that, a layer of woven material, and inside that, again, a layer of aluminium. A single metal is not so strong that the same metal can be cut and spread in 2 or more layers. Every time the ISS passes, micrometeorites as big as grains of sand are attacking it. But it is its bulletproof layers that have been protecting the ISS for the last 26 years. But what will happen if a big meteorite comes in the way of the ISS? It is not as big as a car, but just 1 inch big. In this case, even the bulletproofing of the ISS will not be of any use if it hits at such a speed. The mission control crew on the ground already has an idea of the location and position of the incoming meteorite. If it is harmful, then in this situation the entire ISS has to be moved out of the way. Its trajectory can be changed by using small thrusters installed in the ISS, but these thrusters run on rocket fuel. And this fuel is very less with the ISS, it is only for emergency purposes. To end the dependency of ISS on Earth, a mechanism has been installed in it which easily changes the direction of the ISS weighing 460,000 kilograms without using rocket fuel. Small boxes are installed in its center, which are called Control Movement Gyroscope, or CMG. But how do they change the direction of the ISS, which is as big as a football field? Inside these boxes, flywheels are installed which spin at a speed of 6,600 rounds per minute. Flywheels are like heavy round wheels, just like train wheels. When they are spun at high speed, angular momentum is generated in them. This momentum is transferred to the entire body of the ISS, and thus the entire ISS starts moving in one direction. If the flywheel is rotating very fast, then the direction of the ISS will change more, and the ISS will also rotate in the same direction in which it is rotating. If the opposite direction is there, then the ISS will also rotate in the same direction. If the ISS is to be rotated in the opposite direction, the flywheel is also made to spin in the opposite direction. These flywheels are rotated with the help of electricity, which is generated by the solar panels installed in the ISS. Since we are talking about solar panels, let us tell you that these solar panels are movable because the ISS is orbiting the Earth so fast that the sun rises here 16 times a day, and even when the sun rises, it shifts its position so fast that if the solar panels are fixed, then direct sunlight will not fall on them, and they will not produce electricity properly. That is why these solar panels keep their direction towards the sun at all times. The solar panels installed in the ISS produce 120 kilowatts of electricity at a time. This is the same amount of electricity with which we can easily run 110 air conditioners on Earth. Maintaining contact with the astronauts on the International Space Station was also a big challenge for the mission control through communication radio signals. These signals cannot cross the Earth, and often the ISS is on the other side of the Earth. To solve this problem, earlier airplanes were flown which used to catch the radio signals of the ISS and send them to the mission control in Houston. This method was costly, as well as quite unreliable. Often the communication with the ISS used to get disconnected for up to an hour until it orbited the Earth again and came within the range of mission control. But now this does not happen. With the advancement in technology, with the help of high Earth orbit satellites, the communication problem has now ended forever. Whenever the ISS has to contact the mission control, first the satellite catches the signals, then the same signal is sent to the network of satellites, and then whichever satellite is in the range relays the signal to the Houston mission control. In this way, now with a delay of just a few seconds, the astronauts present in the ISS are able to easily connect with their families. Scientists from all over the world have been using such as food items, chemicals to filter water, spare parts, and shifting of the crew, because an astronaut cannot stay in space for more than 8 months. There are many labs on the International Space Station to carry out different kinds of experiments, most of which are done on the human body. The purpose is only to find out what difficulties humans might face when they go to Mars or deep space. The ISS is just 6 hours away from Earth, but when humans go to Mars, there will be neither Earth support nor will the return path be so easy. Hope you liked our video, so do subscribe to our channel.